Good afternoon, everyone. A very warm welcome to today's webinar. My name's Sam Hart. I'm delighted to be hosting today on behalf of Construction Scotland Innovation Centre. With the help of our experts today, we'll be exploring BIM support tools for embodied carbon, looking at information flows, designing with timber, and specifically the promotion of homegrown timber supply chains. For those of you that know me, you'll know this topic's extremely close to my heart and my work. So I'm really excited to find out more from some of our brightest minds in academia and industry. So without further ado, I'm delighted to introduce you to our panel for the webinar today. We'll be joined by timber and structural engineer Louise Rogers from Edinburgh Napier University's Centre for Offsite Construction and Innovative Structures. Civil engineer Victor Henkel, also from Edinburgh Napier University Caucus. And in a change to the original published lineup, I'm delighted to welcome long-term and serial collaborator John Stinson. Many of you will know John through his previous work with Edinburgh Napier University and also in his current role as chair for the Chartered Institute of Architectural Technologists, Scotland East Region. So each of our panelists will give us a presentation focused on a specific topic relating to their area of expertise, and then we'll have a Q&A session to finish off, enabling you to ask our experts any questions that you might have in relation to what you've heard today. So before we kick off, there's a few housekeeping points I need to just inform you of. This session is being recorded and will be available to view on the YouTube channel early next week. If you'd like to ask us a question or leave a comment, click on the questions tab in the control panel, type in your question and press send. We'll have a couple of poll questions. These will appear automatically on your screen. You'll be given around about 30 seconds to answer them, and then we'll have a look at the results together afterwards. And finally, obviously, your feedback is extremely valuable. So we'll take all questions and comments on board, even if we don't have time to answer them all today. And we'll aim to incorporate those into our other sessions. So first up, we've got one of these interactive questions to get everyone involved. So could we have our first poll, please? So for specifying timber insulation material, which of these is the most important? Normalized price, country of origin, stated thermal performance, fire performance, and moisture performance. Okay, clear winner there. Stated thermal performance being the most important thing when specifying timber insulation. Probably not the biggest shock to the system that we'll have for the day, but 57% there of all of you that polled felt stated thermal performance was the most important. So, okay, I think that's probably enough from me, and time to introduce you to the people that you came here to see. First up, we have Louise Rogers, who's going to give us an introduction into the theory and development of the tool. As I mentioned, Louise is a researcher at Edinburgh Napier University within the Centre of Offsite Construction and Innovative Structures. Louise graduated from ENU with an MSc in Advanced Structural Engineering after the completion of an undergraduate degree in Civil Engineering. Louise has recently begun a PhD which looks at the circularity of the construction sector with a particular focus on the deconstruction and reuse of materials. So Louise, over to you.
Oh, thank you very much, Sam, for your introduction. And I'd like to thank CSIC for hosting this webinar and John for having me along today. I think this is a really great platform to disseminate and inform the industry on what we have been working on. So as you'll know, we're going to talk about this BIM decision support tool for embodied carbon that we at the Centre for Offsite Construction within Edinburgh Napier University have been developing. So I'll just do a quick round of introductions. My name is Louise Rogers. I am a researcher within the Centre for Offsite Construction alongside my colleagues Victor and Andrew. Today I will be going over the development and theory behind the digital tool to give an overview of how the tool was created. Just lost the slides, I'm not sure why. Sorry about that. So following on from this, my colleague Victor, who is our in-house BIM programming expert, he was responsible for creating and programming the tool itself. He will give an overview on how the tool works and ways in which it can be applied. Finally, the project lead, Andrew, has unfortunately been unable to make it today in person, but he has had a significant involvement in this project. In particular, he's provided support to myself and Victor, both as early career researchers, so he is more than worthy of a mention. Gratefully, as Sam mentioned in Andrew's place, John has stepped up to discuss the benefits of the tool like this to the architectural technology industry. Okay, now the introductions are out of the way, let's get into it. It is first useful to give a bit of background on the tool and how it came about. In response to the inherent need for the construction sector to reduce its environmental impact, Scottish Forestry funded a research project with the aim of quantifying the environmental impact of adopting a homegrown wood fibre rich approach to construction in Scotland. In the early stages of this project, it was identified that there was no open source tool or plugin available that was able to quantify the environmental impact of different timber frame build-ups, particularly when it comes to differentiating between imported and homegrown material. So a method around this would be to manually quantify this impact. And if you were wanted to compare a variety of options in the early design stage, this would require lengthy carbon and energy calculations, which is just not a method well suited to early decision making. Therefore, we identified an industry need, and thanks to the output of this work, we are a step closer to making the whole embodied carbon and embodied energy calculation process easier and more straightforward for the sector. So you've had a bit of background on how the project came to fruition. As I mentioned, I'm going to go over the process we undertook to produce the tool, which was carried out in these 3 steps. So the first step was to collect the environmental impact data. This involved identifying all the materials found within timber frame, then collating all of the environmental impact data associated with each material. The second step was to compile all of the data found in step 1 into a comprehensive database. This database allowed all of the collated data to be presented in a uniform manner to make it easier to interpret and then consequently put into the model. Finally, all of the collated data for each materials will be put into the BIM model, meaning the user can design their build-up from the material options, and the corresponding results would be output by the software. So I'm going to delve a bit deeper into how each of these stages were carried out. So when collecting the environmental data for all the materials, we decided to adopt a lifecycle analysis approach. This is mainly due to the fact that this method is adopted by environmental product declarations, or EPDs for short. So in case you're not familiar, EPDs are declarations provided for specific company products. For example, Norboard's OSB or Rockwell's installation. An EPD is a standardized procedure based on a life cycle analysis, which provides the global warming potential, which is measured in kilograms of CO2 equivalent, and embodied energy of the product at specific stages within its life cycle. The table you can see here is an extract of EN 15804, which is the standard to be used for carrying out an EPD. You can see the analysis is broken down into different stages of its life cycle, i.e. product stage, use, and end of life, with these stages being further broken down to sub-stages. In this work, the main focus has been on stages A1 to A4, which you can see highlighted in the table. If we take timber as an example, A1 is the raw material supply, which refers to the tree production, i.e. the planting, growing, and felling of the tree. After this, the tree would be transported to its production site, in this case, the sawmill. The distance travelled and associated emissions are accounted for in stage A2. Finally, A3 accounts for the processing of the tree itself into its final usable state. So in this case, structural timber. So that would be the drying, cutting, clearing, and so on. A4 falls into the next category, and it refers to the transport of the product to its final destination. So here, that would be from the sawmill to the construction site. This aspect is not quite as cut and dry as A1 to A3, as it will vary depending on the final destination. So if you had material which was produced in mainland Europe and transported to a Scottish construction site, the impact would be higher than that of a material which was produced in Scotland. As A4 depends on the site destination, we have kept the distances travelled constant. So that means we've assigned 1 mileage for the imported material and another mileage for the homegrown. This is a bit of a generalisation, but the A4 values are also calculated within the tool as a function of the density. Therefore, they're still representative of the actual transportation emissions. A4 is a value we hope to refine in the future and make more customizable, so you can account for different mileages of different materials. And this is something John will come on to later. So we've covered that we're doing an LCA approach using EPDs. There are a couple of advantages to this method. The first being it is standardized and the results can be compared and combined, which means if you had a timber frame build-up with all the products global warming and embodied energy, it could be combined to give a total value, which is exactly what this design tool does. As well as this, the EPDs are updated every 5 years, meaning you can say with relative confidence that you have the most up-to-date information. Another advantage is that the EPDs tend to be open source, and where they are available, they can be downloaded from the product manufacturer's website. There are, however, a couple of disadvantages. The EPDs are voluntary and therefore are not available for all products, which can cause a problem if you hope to use a different product that's not got an EPD. There's a lack of incentive for manufacturers to produce them, and you rely on companies being upfront about their product's environmental impact. So, and finally, this approach cannot carry out a full life cycle analysis because it is specific on a project-to-project basis. But as this is an early decision-making tool, you would expect a full LCA to be carried out later in the project. So now we move on to collating all of the material information into a database. On the left-hand side, flags have been assigned to differentiate between homegrown and imported materials. In the next couple of columns, you can see the component has been listed along with the actual brand EPD. In some cases, you might have multiple options for one material type. For example, there are 2 options for wood fibre cellulose, one by warm cell and another by thermofloc. This tool gives you the option to choose from either. So we've also included thermal properties within the tool. This is because thanks to some clever programming by my colleagues, the tool is able to calculate the expected U value of different buildups. And this is particularly useful when trialing different material thicknesses, and it saves you from having to use an external U value calculation, thereby increasing the speed of your decision making. Finally, the last columns contain the environmental properties, separating the A1 to A3 stage with the A4 stage. As well as this, the renewable and non-renewable embodied energy have been segregated for reference. And just to clarify, the global warming potential takes into account the associated emissions with both renewable and non-renewable energy. So this takes us on to the last and final stage of the background development. You'll be glad to hear we're very near the exciting stuff, seeing the tool itself. The final stage was to input all of the collated product information into this tool. This included the global warming potential, embodied energy, the density and thermal properties. The user then creates their build-ups, for example, your roof, floor, or wall, using the product options. The software then runs and outputs the components' properties in the form of totals. As well as the embodied carbon and energy, the tool can also output the material quantities, which can be useful from a costing or a transport perspective. So that concludes my section of this webinar. I will now hand you over to Victor, who is going to give you a short demonstration of the tool itself. Thank you very much.
Thanks, Louise. I think this clearly demonstrates a significant step in the right direction, enabling industry to make assessments of embodied energy significantly easier and more standardized. As Louise said, next we'd like to introduce Victor Henkel, who's going to give us a demonstration of the tool and how it can be used to reduce embodied carbon. Victor is also a research assistant at Edinburgh Napier University within the Centre of Offsite Construction and Innovative Structures. He's currently finishing his MSc in Advanced Structural Engineering at ENU after completing a Bachelor of Engineering honours in Civil Engineering. He has previously worked with Carbon Dynamic as a design for manufacture engineer. Throughout his work with Cockis and Carbon Dynamic, he developed academic and practical skills on the use of and application of timber in industry as part of a research group. His primary area of research focuses on the integration of BIM in the offsite and timber industry. Victor, over to you.
Thanks, Sam. Thanks to CSIC and to Louise, and unfortunately to Andrew, who is not here today. to explain it a bit as well. So what you see on your screen right now is the SketchUp software and the tool which has been developed within SketchUp directly. So it has been developed within the environment of SketchUp Pro. So with the dynamic and dynamic attributes of this tool. So first, I'm going to present you the options you can have with this panel. So as Louise presented you earlier, this tool is a single component that can represent a wall, a roof, or a floor, or any full element of a timber frame building. So the first component window you're gonna open is called options, and in there you see different aspects related to your panel, and there the buildup of your panel, which each sublayer corresponding to each sublayer of your panel. So this is an external wall. The internal side is facing me there with plasterboard, and the external side is there with timber cladding. So each sublayer are shown there. So internal finish, battens, insulation, then the timber frame, insulation, battens, and finish again. And all of these can be hidden, so just by clicking no, and it directly adapts and hide the sublayer itself. So by having the option of hiding all of those, you can adapt your wall component, roof component to your proper design, and then within this component option window, you have different results corresponding to your build-up size, width and height, and choice of material origin and choice of material specification. So within the result part, you do have plenty of results such as volume, mass, global warming potential corresponding to the embodied carbon, embodied energy corresponding to the energy used within the different processes of your construction, and finally the object you value, which is directly linked to the type of component, type of wall, type of roof used in your design. So for example, if I do change anything within the buildup of the material, the buildup of the panel, it will directly affect the result there. So I do remove the internal buttons, which are visible in there. Just click apply. The global warming potential linked to the embodied carbon directly will reduce. So I'm just going to show it again, and then present you directly the sublayer of my component, which each of them have different options and possibilities, because is just an entry to have all the options of hiding or showing the objects, and each of the sublayer are specific to each material. So for example, now we go into the timber frame, which have different options, with, for example, having, I'm just going to show in detail this one and just move it on the side for you to be able to see the details in it, because it does have parametric capacities. So when you do change the dimensions of your component, it does directly adapt and update to your build-up you do have. So let's begin with hiding one of the internal sheeting you do have on your studs. So for example, if I do hide this, you can see now that you have different studs, top rails and bottom rails, and different things in it. For example, the type of studs, which now became I-joist instead of studs, to be used as, for example, a floor or roof cassette. Then you can change the centers, for example, of your stud, and it directly adapts to the dimensions of your wall. Also, you can change proper dimensions of studs, joist, etc., etc., such as well like the sheeting geometry linked to the or plywood sheets you're going to use, and relation between the studs, which is really important as well, where you have different options, as Louise introduced earlier, with different options of insulation. After this, you do have to choose the type, the origin of your materials to have the exact environmental impact of your building or wall or object. And you can choose for each of your material used within this sublayer the origin of material. And for example, for the timber used for rails and studs, it either can come from EU or Scotland directly. And if you do change the origin of material, as I just done now, you'll see that in the result part at the bottom of your screen, at the bottom of the component option, will change. So if I do have a look into the global warming potential of solid timber in there, and if I do change timber type from homegrown Scotland from to and to EU, it will directly change the global warming potential of solid timber in there. Then the main capacity of this component and tool is to adapt to different designs, shapes, and projects. So I'm gonna show the capacity of this model to adapt. And for example, I'm gonna create an opening within this wall just by doing just by stretching the wall, adapting its length, width, and width, and just create by having new parts. Sorry. So by having this capacity, within your early design stage, you'll be able directly to design your house with proper build-up. You won't have detailed drawings as the build-up directly adapts from the size you do have. So in this scenario, I do have an opening created within seconds that does have the same build-up as others, and that can be used as a production drawing as well, because it does have the layout of studs and rails. So it can be really relevant for your early design stages. Following this, in addition to, I would say, the 3D the model, it can report directly in an Excel format the environmental properties and volumes and mass and different attributes related to your wall component in there, or to your full design as well. So just as a try, I'm going to show you how to export values directly from the software to show that changing, for example, the origin of your material will definitely change the environmental impact of your building. So let's change every solid timber origin from EU to homegrown. So I do have solid timber in there that I'm gonna adapt and change to homegrown. And I'm gonna change the vertical battens to homegrown and the external battens to homegrown as well. So every solid timber used in this wall panel is homegrown. And I'm just gonna copy paste it 10 times just to have like bigger values to represent just a small house. And on this one, I'm gonna have the imported values. So imported, then imported for timber, and again imported for timber, and again just copy paste it 10 times to compare. There we go. Yeah, it's just a different spacing, but then I just go select all and goes within the report that is already prepared within the tool that will be made available afterwards. So everything that I'm showing right now is whether going to be as it is right now or updated. So for example, within my reports, I can report the volume, the buildup, or the volume of materials. And so by showing just by running the volumes of material in there, it's gonna create an Excel file with all the attributes. Oh, seems it doesn't work, but I already have the Excel file prepared. That's fine. So I do have two different Excel files with different attributes, with this one related to the wall component I had with imported timber corresponding to the EU, and in there the same wall but with the homegrown options. Those two values correspond to the embodied energy and the embodied carbon. So as you can see in this homegrown scenario, there's way less embodied carbon than the EU scenario. And as well, in addition to the environmental attributes, you can export the mass of material. So in this scenario, it was weighing 16 tons. So it could be useful for logistics as well, if you do want to transport and have further studies on what to do with your wall. And it has multiple options of reports as the wall does have export volumes, environmental attributes, U values, and mass. So it can be used in several aspects of your project. And to finish with, as an example, this house was created only with dynamic components and was directly used to estimate the environmental attributes and the U value, volume, and masses. Yeah. I've finished, Sam. Still there?
Thank you, Victor. Brilliant. Another great presentation, and really interesting to see how a detailed digital model can so effectively be adapted using the tool relative to the origin of the raw materials. Brilliant, absolutely brilliant. So before our final presentation, I'd like to propose some more audience engagement with another question. So if we could have our second poll, please. Here we go. Are the results from life cycle assessments currently within your organization's specifying decisions? Yes, no, I don't know. My organization doesn't specify materials. Drum roll. Great, positive news. Almost half of all organizations here have responded yes to having that ability. So yeah, that's good news. 33% no, 13% don't know, and 5% organisations don't specify material. So good to see, with more work to do, I think. Okay, so on to our third presentation, and as previously mentioned, unfortunately Andrew Livingston can't be with us today. However, hats off to whoever negotiated this deal before the transfer window closed last night. I'm delighted to welcome John Stinson to the webinar. John is Technical Director at Building Research Solutions and Chair for the CIAT Scotland East Region, having previously worked alongside Cockis as an AT Research Fellow at ENU for 13 years. John's standing in for Andrew, as I said, and we'll discuss the benefits of using this BIM tool for construction professionals, how it can be added to existing workflows, and areas for further development. John, over to you.
Superb. Thanks very much, Sam. And a special welcome to all of the architectural technologists in the audience today. CIAT Scotland East Region Committee are always happy to collaborate and disseminate innovative information within the AT profession with our friends at CSIC and Edinburgh Napier. And again, just to echo the apologies from Andrew Livingston for being unable to be here and present to you all today. And just to reassure you all that Andrew and I have discussed this particular part of the presentation over the last few days, and myself and a few others within the CIAT Scotland East Committee were part of the beta testers that were able to play around and explore and stress test this BIM early design stage LCA tool. So Andrew is still very much a part of the R&D team and contactable if you want to discuss or get involved with applying this tool to your projects or to your decision making, or have any questions about what I'm going to speak about just now. So this afternoon, Andrew wanted me to wrap up this knowledge exchange event by covering 3 topics: the actionable intel that this tool can provide when applied to real-world industry settings, how and where this tool can be embedded within existing workflows and software within your organization, and finally, a few of the functions and features currently in development. And I'll end this part of the webinar with details on how to get involved with this tool and get involved with the development team at the Centre for Offsite Construction and Innovative Structures. So prior to this event, a number of CIAT Scotland East Region Committee members were involved with using and reviewing this tool that Victor has just demonstrated. These people applied the tool to their existing projects, and they represented construction professionals that work in private architectural design practices, timber frame construction system providers, and energy and sustainability consultants. So with the interviews and some thematic analysis on the keywords that the user advisory group had used, The tangible outputs of this tool provides a few key advantages to those wanting to explore embodied carbon and a move towards specifying more homegrown timber products within their supply chain and within their current methods of construction. So some of these key words that came out were actionable intel and support when designing to internal and national carbon and sustainability targets. A graphical tool that allows the user to go further by providing a visual model when assessing the different timber panel formats and configurations. And from that, then there is it allows for scenario balancing, which allows the user to visually evaluate the effects of material selection versus operational energy through the tool's simplified U-value calculator versus embodied energy and embodied carbon and its global warming potential. The tool's material choice within the library also allows for an element of rapid prototyping for designs that may not have been previously considered. And then it also allows for quick optioneering to influence decisions for optimizing and modifying supply chains. And all of that then, all of those different critical points on the decision-making pathway all culminate into something that looks like, or that can look like a scenario matrix, something that Victor had described in his example there, where you have as many options as you want to explore, and including different alternative materials and configurations to internal finishes, insulation, and external finishes, with options based on type and origin to undertake a type of comparative investigation. So these scenarios that can be as an output, as a tangible output from the tool, allows for variables that affect transportation consideration, like volume and mass. And finally, working in that spreadsheet ecosystem platform of Excel or something similar allows the user then to rank and prioritize the low regret options from the different scenarios run with that tool, and then it allows that particular organization, depending where they are in the overall design and construction of the panel, to move towards a real world R&D pilot or demo or trial. So you get a lot of really important and influential information early on without having to commit too many things, and slightly de-risks the process. So this is a workflow that represents a simplified pathway that many of us will be familiar with. And because we're talking about a digital tool here today, this list only shows the common or indeed the compulsory software within the construction industry that plays a valuable role within aesthetic design, structural design, and operational energy design, with an emphasis on safety and designing for lower operational carbon emission targets. So now, using the feedback from the industry user advisory group on this tool, the new and digital embodied carbon tool that currently focuses on cradle to practical completion can be mapped onto this workflow at three critical points. So first, at the very early design stage, using a simplified normalized elemental model, so something like what Victor had started off with like a meter squared or a meter cubed of a roof or a wall, then running various scenarios with different homegrown options and materials to achieve whatever embodied carbon reduction that you're going for or that you're looking to see within your method of construction. This would then go on to inform panel shape, panel size, and the mass before moving into specific architectural and structural software, just to kind of sense check some of those design decisions within this particular tool. Also, or indeed independently, this tool can be applied to the stage after geometric and structural values are set, using more confined input variables So the embodied carbon tool can be used to influence decisions on insulation material selection based on origin and thickness and such. So whilst the tool does have a built-in U-value calculator, the decisions made on insulation material based on its effect on embodied carbon would then be evaluated through other software specific to more holistic operational energy assessment for at component level, or indeed at building carbon evaluation level, which also allows you to investigate things like hydrothermal performance as well. So finally, and if you've used the tool throughout this workflow, or if it's only being applied at the end of going through those other stages first, this tool, as Victor has said, can produce technical drawings, and as Louise had mentioned, it also can produce life cycle assessment and life cycle inventory technical reports for carbon reporting once all those decisions are in place. So this is my second to last slide, and Andrew wanted me to stress to you all today that the digital tool, whilst it is BIM enabled and provides valuable information and metadata for building information modeling specific to embodied carbon, it is still very much capable of a lot more and can do so much more. So speaking with Louise and Victor and Andrew over the past couple of weeks, they have listed these as areas in which the tool can expand. So areas like optimizing the graphical user interface, the user experience, and user input processes to add unique defined components, expanding the type and quantity of embedded materials in the libraries and databases, calculating condensation risk to BSE and ISO 13788, enhancing stage A4 calculations, and as Louise had mentioned, that's the transportation stage in the LCA methodology, so providing a greater selection on locations and travel and distances from factories to site, and then building in a stage 5 calculation, which is the construction installation process stage in the LCA methodology, incorporating more of those EPDs that Louise had mentioned. So just at the very end of my slides here today, before I pass back to Sam, the Caucus team are continuing to work to develop this tool with the vision of supporting architectural and construction designers to specify more, or consider specifying more homegrown timber materials, and to get more valuable insights into whole life carbon, embodied carbon, before calculations for operational carbon. So adding this to existing workflows, existing decision making, so that we're expanding our horizons as designers and as construction professionals beyond just operational carbon. But much of what must be done needs to be based on what the construction industry wants and needs, and what part of the tool means most to you all. So Andrew wanted me to do a little bit of a kind of call to arms. So if this is an area that you're interested in, and embodied carbon of materials selection is something that your organization is trying to get to grips with in terms of timber framing and timber frame method of construction, then please do get in touch with Louise Rogers, and the email address is on the last slide there. And then through that collaboration, they can work together to make it more holistic and where the tool needs to go to. So that's it from me today. I hope that you enjoyed the presentation this afternoon, and I'll hand back to Sam.
Brilliant, thanks John, and thank you again for stepping in, because I did hear some whispers that Andrew might have asked me to do that bit of the presentation, which would have resulted, I suspect, in some very swift drop-off rates of attendees at the webinar there. So thanks again. So before we head into our Q&A session, we've got one final question to ask the audience. So if we could have our third poll, please. What BIM-enabled software are you using? Vectorworks, ArchiCAD, Trimble Platform, Autodesk Revit, or others? goodness, quite quite significant number of you out there using Revit with Trimble, probably Trimble in second, ArchiCAD, Vectorworks, and no one else using anything else. So Autodesk clearly the most popular software there. Okay, folks, I think the questions have been coming in thick and fast. So apologies if we don't get through to them all. But if I could ask the rest of you to switch your cameras on. And I've got we've got a number of questions here. The first two of which could probably be answered in one. I'll read it out. One of the issues with timber frames supplied in Scotland is the section sizes available. This can be overcome by utilising composite timber sections composed of plyweb and smaller solid section sizes for beam flanges. This potentially has timber coming from more than one source. Can the system take this on board? It will give a more complex result. I-section comes from one single manufacturer, but components may come from various sources. And perhaps we could combine that with another question, which is, could this tool be expanded into include other construction materials, e.g. concrete or timber, to compare, e.g. concrete to compare against timber? Louise, do you want to have a shot at that?
Yeah, I do. Thanks very much for your question. So referring to the I-beam, I-section, I-joist part of it, there is actually already an I-joist within the tool itself. So James Jones, they have produced EPDs, so that is in the tool. When it comes to something a bit more complex, like you're combining multiple sections, you could certainly do it, but you would have to have your background information on your EPD. So if you're using two different components, you would have to have your timber flanges and your OSB web. You would have to have your EPDs for both of those. And then you would have to have your ratios of each, which would contribute to your emissions associated with that. So that kind of comes on to the second question related to that about specifying your own materials. So currently the tool doesn't have that option, but it was something that came up in the feedback, was the kind of user component specified option. And that's something we're going to look at doing in the next development of this tool, so you'll be able to specify your complex I-section and so on. Hopefully that answers your question. So basically, if you have your EPD for all of your components, you can do it.
Brilliant. Thanks, Louise. Another question here: how easy would it be to use the tool in a retrofit context, and is this being considered for future development? Victor, do you want to have a shot at that?
Yeah. So in terms of retrofitting, it wouldn't be so much different than a new project, because the retrofit would be just a wrap around another building, and as it can be used as a design tool, you would just have to get your build-up that you're going to use for retrofitting, and then you would have, for example, your volumes, mass, and environmental attributes, as well as the U values corresponding to the element you're using for retrofit.
I might just jump in there as well, Sam, if that's okay. It would, just to kind of put my comment on it, because we do a lot of retrofit work as well, and especially with buildings that have large thermal mass and need to have some element of materials that have a breathability quality, certainly hygroscopic and vapor permeable, like some of the wood-based insulation materials. It would be interesting, and I'd love to see this particular tool moving towards having other substrates. So instead of the kind of having the open panel timber frame there as the core, that's perfect, but also then having maybe a solid stone wall perhaps, or kind of a traditional build, thin cavity brick and brick kind of construction, and then framing out on the inside with a timber framing system with a wood fiber or hemp fiber, something would be a lovely way for this to go, especially as we're considering mass retrofit and everyone's focusing on it in operational carbon on that at the moment. It'd be great to kick that conversation open. So again, another great area of development that could be included with the next phase of this tool.
Yeah, good shout. Louise, this is probably one for you, given the presentation. Including stage A5 from EPDs, stage 5 in terms of building construction is very site specific and can taking data from EPDs, if it's even reported, which it really is, ever be considered relevant?
Yeah, so you're quite right. Stage A5 is rarely reported. I don't know if in any of the EPDs I looked at for this project, if A5 was ever reported. And you're right, because it's so site specific, it will change depending on where you're change on your construction method and how you're putting things together. And that might be different, you know, if your A5 will be different if you're going to be in factory conditions, and if you're going to be doing it on site. There's quite a lot of variance that can come into that. I believe Victor has worked a little bit on the A5 for his dissertation, which he just handed in last week. So maybe he would like to talk a little bit more about how you could maybe go about the A5 if you were to include it.
Yeah, so actually within my dissertation, I quite had a look to the stage A5, but not in terms of environmental aspect, but more in terms of the way you do transport things. And as Louise said, there's site specifics, and while you trying to adapt each project to a value, you can't really summarize something, and you can go within the transport or in A5 or construction, but yeah, no, it won't be made available like for stage 5, not really.
But it's definitely something I think we can look at developing further. You know, we're always looking on ways that we can simplify these processes and include them where possible. Sometimes it's not, but we certainly give it a good go.
Good stuff. Good stuff. Another question's come in. Does this tool consider end-of-life treatment? In life cycle assessment, end of life must be considered in a full and true assessment. It's very difficult to claim a carbon benefit without accounting for this. Eeny, meeny, miny. So, John, do you want to have a shot?
Yeah.
Nope.
That's okay. That's fine.
I'll have a crack at it. It's something that we have done recently as well on a few other projects, and it's something that's really hard to quantify. A bit like A5, which is your kind of the construction processes related task. It's hard to be site specific. It's hard to know what actual method of construction they're going to use and what tools they're going to use and manpower and things like that. What would be really good kind of in tandem with a tool like this is continuing with the work, with the R&D work at Edinburgh Napier with Louise and Victor and others to start building kind of benchmarks for some of the end of life scenarios. And one of the hardest things to really map onto a tool like this for end of life scenarios is the grid decarbonization and just how much of the electricity being used to power those recycling, repurposing or recovery methods is coming from green electricity or blue electricity if there's hydrogen coming online, and it's about kind of tracking that. So this would definitely be something that would need a couple more PhDs out of it, I would have thought. Over to you, Louise, if you've got anything to add to that.
Nothing particular. I think so. Obviously, my PhD is looking towards it. I'm just started, so it's looking towards. It'll be very focused on the end of life of products, and in particular how we can reuse them instead of putting them into landfill or using them for biomass, whatever we decide to do. So I have been thinking about this tool a lot and how we can do that. So it's potentially something that I will continue with in my PhD over the next 3 years. But I'll get back to you on that if I do.
Yeah, it's all about defining those benchmarks and kind of getting some rule of thumbs into place. That's one of the hardest. We went through this, 30, 40 years ago with operational carbon, whenever everyone was going nuts to benchmark things for SAP and SBIM and RDSAP, just trying to get those lookup tables in place. And that was a monster amount of work trying to get that for U values, thermal conductivity, and bits and pieces like that. So it's a big task, but the nice thing is with a tool like this is that you've already demonstrated the proof of concept that allows us as construction professionals to consider things around material selection at the start of the life. And in the next few years, whenever it becomes clear if we are going to drop a lot of hydrogen onto the grid, and if we're going to kind of optimize some of these recovery strategies, then that would definitely make that benchmarking and those matrix tables for reference a lot easier to quantify. And then it makes you guys who are developing the tool, it's much easier then to just kind of add those calculation formulas into the back end of the component part of SketchUp.
Yeah, and so if we are talking about these kind of next iterations or next steps, Louise, where do you see this tool being used in the future?
Yeah, so it comes back to a couple of the questions that we've already had, on the A5 and end of life, and how we can perhaps try and incorporate into those, and whether I continue with that research myself or we do it. This tool is currently used on the Edinburgh Home Demonstrator project. I don't know if any of you are familiar with that. But it will be heavily utilised on that. As well as that, we're hoping to make it available open source. It will be available open source. We're just not quite sure of the timescale yet, and where it will be hosted. But that will give a good opportunity for industry to really get a feel for it, and give us their feedback. There will be opportunity before then, as John mentioned earlier, to get involved. If it's something you want to try out just now, then we're more than happy to share it with you. All the kind of feedback and criticism is definitely useful, because we want to make this really kind of a tool for industry and something that is available freely and that can really genuinely help. We all have the same goal of reducing our environmental impact. It's becoming critical, so I think this is a good step in the right direction, and any help from industry is absolutely welcomed.
Yeah, I would echo that as well. I would say that there will come a time whenever reporting of embodied carbon, especially stage A1, 2, and 3, is going to become mandatory. We're seeing some of the key players who developed the SAP methodology saying that we need something to take consideration of stage A1, A2, and A3. So getting ahead of the curve and being an early adopter in this one is certainly something worth investigating.
Mm-hmm. Yeah, absolutely. We've got a couple of specific questions that have come in. Victor, you probably help with this. Does the tool use virgin timber, or can it account for reclaimed, recovered, and recycled timber in the supply chain?
It does have virgin timber in the database right now, but as Louise said earlier, EPDs are based on manufacturers' material, and based on, as it's not necessary right now for manufacturer to do it, reclaimed material seems to be as well not that common right now. So there's even less CPDs than for virgin timber. So there's just virgin timber in the database right now, but once there's data for reclaimed or other type of timber sources, there could be definitely values for this.
Yeah, and I'm just thinking off the top of my head, I think you have colleagues, don't you, that are working on the projects looking at strength grading and other bits around reclaimed timber at Caucus. Brilliant. And then probably time for one final question. Louise, will the mass of the designed panel affect the emissions related to the transportation?
Yes, it will. I kind of touched on it very briefly in my slides. So the way the emissions were calculated for the transport was based upon literature values, pretty much, and a study carried out by Homegrown, which I think is quite highly regarded. Anyway, so they're based on the emissions due to mass, so the fuel consumption that is influenced by the mass and density of the panel. So the heavier a panel is, the higher emissions will be, and that'll be reflected in the tool.
So I'm assuming that will be ton per kilometre values.
It is, yeah, yep. Mm-hmm.
So it's a normalised value, so it kind of it multiplies.
That is exactly what it is, yeah.
Perfect.
Mm-hmm.
Fantastic. Right, well, I think that's probably our time up. Thank you very much, all three of you. I think it's been really insightful, been brilliant to see the work that's been undertaken at the moment. Thanks to the audience and all of you for joining us and for all the important questions, and obviously for generating all the insightful discussions. We have posted a few details of relevant links, etc. If you haven't, please download. Please remember to download any handouts from the chat box. And as I said, your feedback is extremely important to us. So if you could just take a minute to fill out the feedback form after the session, that would be fantastic. So that's us. Thank you very much again, and look forward to catching up with everyone soon. Goodbye.
Thank you.
Thanks, Sam. Bye-bye.